Good day. My name is Bongsani David Kanyila, a student number of 15305783. This module is called Water Infrastructure and Resources Management, which is WRM307. The project is based on analysis of water supply, as we know that on a daily basis, the need of water grows as the population grows. If a suitable water distribution network are not built, it will have an influence on the water supply of the entire region, which is can be your farm, your township, or your city. Before developing a water distribution system, an in-depth assignment of surrounding accessible water resources, present distribution network, water demand, and needed discharge, and among other things, is required so that you can do a proper or design a water distribution system. As engineering technologist, I've been appointed to make an analysis of water supply projects to be implemented by the Pise local municipality. This project is intended to provide water supply to 5 townships in line with its water service development plans. I'm expected to determine the following: number of pump station required, storage capacity of bulk reservoir, head loss of each component, hydraulics profile for pumping mains and pipe sizes, hydraulics profile for gravity mains, and evaluate the need for pressure and surge control. Most importantly, the water system must be designed to achieve appropriate water pressure, flow, and to avoid contamination to a potable water. As well as achieving the right pressure, flow, the system must be suitable for the temperature of water carried. A well-designed and installed system will, will be durable, minimize the noise of the water flow, and from the problems such as water hammer, and support efficient use of water. Now we'll look at the background overview. A water distribution system consists of a complex combination of components, including your pipes, your fittings, your pumps, your reservoir, your valves, your hydrants, your meters, and a backflow preventer that are all critical in maintaining a physical integrity. At the same time, distribu- the, the system is constantly changing through aging, replacement of component, and addition of new extension. As we know that we're living in the 21st century and the technology has highly dominated our environment, our lives as well. We have to consider the following when we're designing a water distribution system. A system must be able to supply and deliver water in acceptable quality to all users and all citizens. The water is one of the most important factors in ensuring that the public safe and continuous operation in urban and rural activities. In this manner, careful preparation of infrastructural planning, resources allocation, maintenance, and allocation of activities is very essential. We have to also think or consider maintenance of water distribution scheme. If correctly used, we will keep the money, save the money for the government in terms of in terms of avoiding to maintain the system in each and every week or a month. So if a proper water distribution system has been designed or built, then we'll save the government so much money of fixing or maintaining the system. But we'll also improve the government service delivery, will improve satisfaction of customers and their general quality of life as a resident of this country. The following daily demand that is being proposed by Etsepisa local municipality is as follows. We're going to look at we're going to design for 5 townships for a daily average demand of the following as well. For township number 1, it's going to be 62. For township number 2, it's going to be 63. For township number 3, it's going to be 78. For township number 5, it's going to be 64. The proposed layout, the general layout of the proposed system is as follows. We're going to look at how initially is designed. As we see from there at the bottom, we have a river which is called Nyangwe River. From there, we have a Shikahilo water treatment plant. And then from there, we have a bulk storage reservoir. And also, we've got junctions, pipes, and demand sensors, which will be the townships. As we know that, as I've mentioned before, that we've got a 5 township to design for. And we're going to look at the general layout of the townships, which is township number 1, number 2, number 3, number 4, number 5. We have to consider the Shikana Hill, and also we've got a very we're lucky because we've got a river at the bottom which we will abstract water from. Now let's look at the literature review. A water distribution system are often owned and managed by municipalities, bodies such as cities, metros, and also districts. Although the private companies operate them on an irregular basis, for more than a decade, water shortage has been frequently something that happens on a daily basis, whereby during winter we dry up, especially in our country. But the rivers also always keep their massive sand lines until the middle of summer. So the rivers plays a huge role in terms of um, to avoid water being dried up, and also to avoid a day whereby it's a day zero water. So rivers plays a huge role in terms of water being extracted from. Now we'll look at the classification of water supply systems. Water supply is also very important for business, industry, to be able to operate in a municipality context. It is also vital to guarantee that the water is provided to strategically located fire hydrants in order to provide the public with an appropriate fire protection, which is very important. Municipality water system may be obliged to provide water for specific services such as street cleaning, selling of water to contractors for building, construction and parks and recreation, and other activities. Layout of distribution system. We will consider the following, which is the ring system, dead end system, grid ion system. Now we're going to look at the most important component of this report, which is the methodology. We're going to look at the components which I have mentioned before, which are pipes, tanks, reservoir, junctions, and pumps. These are all components that make up a well-designed water distribution system. Pipes plays a huge role in terms of linking or connect the networks. Tanks in terms of storing of water. Reservoir in terms of holding the water before it gets supplied to those demand centers. Junctions also, they enter as escape. Some of the most fundamental input data for water quality are water demands, baseline water quality. Some of the outputs are computed in hydraulic head and pressure and water quality. And lastly, we're going to look at the water pumps, which pumps or put a pressure to pipes in order to supply those demand sensors. Now we'll look at the Ethernet, which is the system that we are going to use to design this water distribution system required by Tepise local municipality. So when you're dealing with Ethernet, you consider the following that I've mentioned above, which is your um, your pumps, your tanks, your reservoir, your junctions, and your lastly your pumps. This all those components form a proper water or well-designed water um, distribution system, which we're gonna be designing on implements. As you can see the diagram, as I've also plugged in all the details that were required by um, 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 it's a piece local municipality. Now we look at how we set up the water supply networks, which is we have to plug in all your junctions, your pipes, your um, junctions, your pipes, your pumps, your reservoir, your demand sensors, and also most importantly your the water storage, which is a reservoir. Now I'm gonna show you how you portray the demand sensors, how you plug in the demand sensors, elevation and base demand of the water distribution system. Remember, these components also plays a vital operation in terms of how you put them, because at the end of the day, it's the system or Ethernet will show you if you have plugged in the correct or it could easily pick up an error if you've plugged in incorrect points in terms of your diameter, which is very important, which I'm going to explain later on how it affects the system as a whole, how it affects or how it plays, how it will affect the system as a whole in terms of being positive or negative. So now, since we've installed the demand sensors, which are very important, which are our townships, um, and also installing the pipes, we'll now look at installing the tank at Sikash Hill as per specification required. I've detailed everything on the reports, which will portray in terms of the specification that are required by municipality. Now we will we as I've mentioned before that we insert these components which I've mentioned before, which are your pumps, your reservoir, your pipes, your demand sensors, and also your junctions. Now that's where I inserted the junctions elevations. And the following we insert the pipe lengths and also estimate the diameter so that our pipes can be um, um, very durable and also very or satisfy the design that is required. So after plugging all those components, your system will automatically shows that you have nothing negative or everything is being designed properly by saying that the run has been successful. So this is the Ethernet that designs or creates a water distribution or a well designed or a well safe water distribution system. Thank you.